Welcome to lesson 5-3, sine and cosine functions. So the objective of this lesson is to extend the definitions of sine and cosine for any angle. So as you can see in the previous lectures, in the previous discussions, we have introduced the sine function, right? So we have tackled a bit of the sine function, especially its graph, which is sinusoidal. So as you can see, this is a bit familiar, right? And that is the sinusoidal function of the roller coaster, the Ferris wheel, the Ferris wheel. So in this lesson, we are going to extend the definitions of these sine and cosine functions. So what are these functions? Okay, first we start with this graph. So this is the graph of a sine function. The graph that you see here is the graph of a sine function. And sine function and cosine functions, this is cosine function, okay? So sine functions and cosine functions are both sinusoidal. And as you could see, they have a similar pattern or periodic pattern. So they stem from -1 for their minimum up to +1 for their maximum. So that's how they behave. They are oscillating, rotating, what else? Sinusoidal, periodic. Those are the terms for these functions. So in detail, we are about to discuss the characteristics of the sine and the sine function. Okay, so let's begin with the sine function. A sine function, as we did in our grapher, let's say I have y is equal to sine x, so that y is a function of the angle x. And if I am to create a table, okay, I'm going to create a table for the angular value of the x to show the value of y for each x. So let me have at least 6 cells for the values of my x. And x here is in terms of angles. So what is the first thing that you have to understand about these functions? The first thing is that these functions are periodic. And these functions are, what do you call this? They are functions of a circle. They came from a circle, from a rotation, from circular motions, okay? From a sinusoidal motion. So our x are angular. We just vary the angle x, and then we get our y, which is, of course, if it's a circle, let's say it's a unit circle, with a radius here, I mean a diameter here. So they have the intersection as the origin. Okay. So if we have a circle, this value or this function is just rotating. It's just rotating. Okay. So the more vibrations per second it spends, the more rotations and revolutions it takes. Am I correct? Therefore, as we described in the previous lesson, we have this reference angles, and you could see that the revolutions repeat. I mean, the period repeats, therefore creating more revolutions for more value of angle. Let's say my angle is theta is equal to 720 degrees. I have 2 revolutions here, meaning I have 2 complete circle here. Okay, so that is where the idea of sine and cosine function came from. In essence, you could see a 1 and -1 here, because this function, sine and cosine, came from a unit circle. Well, a unit circle is a circle whose radius is 1. So let us extend this axis that I did from let's extend it, okay, outside, so that we have an x-axis and a y-axis taken. So this is our x and this is our y-axis in a regular Cartesian coordinate system. And the value of this is 1. So this is 1, negative 1, 1, negative 1. Look that this is a unit circle. So sine and cosine functions are taken from a unit circle. So rotating around a unit circle with varying angles, that is where sine and cosine came from. So we go back to this table. Let us say my position is at 0 degree. And I go, or I move to a theta, or an angle, or an x angle of 90 degrees. And then I move to 180 degrees, and then 270 degrees, and 360 degrees. And then, let's say only up to here. Okay? And then we have 720 degrees here. So, as I move along, now those points are actually these points. 0, 90, 180, 270, 360. So those points are the endpoints of the radius. Okay? The radii and the endpoints from the unit circle. So these are the maximum intervals for the x and the maximum range for the y. So if my x is equal to 0 degrees, just get your calculator and substitute 0 for x. So that would be sine of 0 degrees. That would be 0. And this is 1. This is 0. This is negative 1. This is 0. And this is 0. So now I'm going to create for this pi here. I have what do you call this? I will create another Cartesian coordinate. So from this angle, okay? Or maybe we could just plot him here to see how these 2 points are confirming each other. So let's graph the 0 degrees and 0. So it would be here. If x is 0 degree, then your y is 0. If x is 90, this 90 is here. This scale here is 90, then it's 1. If your x is 180, then it would be 0 for y. And if your x is 270, the value of your y is negative 1, so it has the minimum now. And 360 it's here. And that is defined as one period. So if we're going to connect the points together, if I'm going to connect the points together, so I will have this curve. Should be a smooth curve. Okay, now this is considered as one period. And you can see that it continues. So from here up to here, that's second period, or that's 2 periods already. So here to here, up to here, I'm sorry. So here, from here up to here, that's another period, because that's another circle. 0 to 360 is 100, is one revolution or one circle. 360 to 720 is another circle or another revolution. That's why in the given here we have 2 periods at least, and that is the value of your angles and your sine theta for a given x value, which is in angle. So this is our sine theta. And taken from a unit circle, it has a maximum range of 1 and a minimum range of -1. So let's go to the cosine. This is the cosine theta. Now let's create another table for cosine theta. And let's say we'll just copy from here. Let's copy from here. So all we need to do is to change the, we're just going to change the so in here we're just going to change the y here, because for example we have another function which is y1, or let's say this is y, okay? So let's say we have y is equal to cosine of x instead of sine of x. Then let us erase these values for y, and then let's get the value of our y for cosine of x. So when our x is 0 degrees, get our calculator and solve with me. So cosine of 0 degree is equal to 1. Cosine of 90 degrees, so that's cosine of 90 degrees, will be equal to 0. Cosine of 180 degrees, so that's cosine of 180 degrees, just change your 90 to 180, that would be -1. And cosine of 270 degrees would give us 0. And cosine of 360 degrees is equal to 1 again, so 0, 1, and this is also 1. So take note that, let's just use this graph here to plot all the points that we had. So if x is 0 degrees, it's on the middle, right? That the value of your y is 1, so it's exactly there above. And if it's 90, this is 90. These are scales of 90 degrees. So 90, 90, 90, 90. So that's 360 for 4 90s, right? For -1, it's 180 degrees, -1, and this is 0. And then we have 360 degrees, it's 1. So combining or plotting the points together, so we connect all of the points. So connecting all of the points will give us this curve, and that is 1 period. So this is 1 period. Okay? And this is for cosine of x. X and theta are similar in that theta is an angle and x also is an angle. Now the only thing why we wrote y is equal to cosine of x is to explain that this cosine of x, or the y itself, is a function of the cosine of the x, where x is an angle. So it's similar to y equals cosine theta, and that's why we have the same graph. Only that we changed theta to x to show a function relationship between your y and x. So in here we have another period. This point covering up to this. So we have exactly, or at least 2 periods given in y is equal to cosine theta on this graph. So this is our y is equal to cosine of x. Notice that our range is the same as the sine. Our range here is from -1 to 1. And our domain here is in terms of theta. So x is element of R, and it's in any angle. Okay. So it's the same with the range and domain of our, what do you call this, of our sine of x, which is on the previous slide. Okay, so what is a periodic function? A periodic function is a function whose values repeat at regular intervals. So as I've said, a periodic function, from the term itself, periodic, it repeats, it has periods, and it repeats at those periods. Okay, so given this, we have one period, and then we have the next period. So now we have two periods, and then it continues. Okay, up to a certain definite theta, so a certain definite rotation. So the definition of periodic function, the function f is a periodic function of x. So it oscillates through x if and only if there is a number p for which f of x minus p is equal to f of x for all values of x in the domain. So meaning you have this p, which is the smallest number, which is the period. So in other words, taking this into concrete example, we have example x minus 30 degrees. So this is equal to f of x. They are equal. These are just periods. So this is more than one period. Okay, these are periods. And this p here is the smallest number called the period. So this one is our period. Okay? So that is a periodic function. You get it? Okay. Now all that this just means that if you started from let's say 30 degrees, so from here, and then you oscillate, you rotate up to this period here, then you can define this as your periods. Okay? So this going to here is one period, and you have this red here up to this is another period, and so on and so forth. So that is the definition of a periodic function.